Hey folks, Mrs. Woodyard here. All right, so we're on to a new unit, fresh start. What we want to first do is to talk about the quadratic formula. So before, when I've been asking you to solve for x, we've had two different tools in our tool belt. Number one, we have factored. Okay, we have factored an equation, set everything equal to 0, and then use our factoring of quadratic skills to be able to solve where x equals or where the equation equals 0. The second method we've been using is completing the square. So when factoring falls through, it's generally easiest to factor, but when factoring falls through, we can use completing the squares. When completing the square looks way too difficult, what we want to do is we want to use that quadratic formula. So if you want to turn into your textbook on page 213, you're going to see something that looks like this, okay? It's a whole page of how the formula has been derived. I really encourage you to read it, but I'm not going to test you on it. So if you're the type of person who is like, holy moly, I need to know where this formula has come from so that I can fully understand how to use it, go through that proof. Otherwise, I think it's okay if we just go through what the formula is. So again, how to derive the formula on page 213. Let's start the notes. So 3.1, solving using the quadratic formula. Remember guys, our quadratic formula is ax squared plus bx plus c equals 0, where a cannot equal 0 and b and c are integers, or are elements of the real. Okay? It can be any real number. So that also includes 0. So if you have an equation, say, like this, x squared equals 0, we could say three things. We could say that a equals 1, because that's the term, and that's the coefficient in front of the x squared. We can say that b equals 0, and we can say that c also equals 0, because there's no x term, no just plain Jane x term. Just like there's no plain Jane constant term, okay? So then the constant is 0, and the coefficient on the x variable is also 0 for this one. We need to use this knowledge of what's a and what's b and what's c for the quadratic formula, because here it is, folks. The quadratic formula is it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you're looking at this and like, what's all this a's, b's, and c's? It's just the coefficients on the various variables, or in the case of c, it's just the constant. Okay? Great. So if you have a quadratic formula, this is another way to solve. So now we have three ways. We have solving by factoring. When that falls through, use completing the squares. When that falls through, use the quadratic formula. Because, yeah, it'll get the job done, but can you imagine plunking everything in here? Well, we're going to be doing examples of that, and it can get a little tedious. Okay? So step 1, factor. Can't do that. Step 2, complete the squares. Can't do that. Step 3, quadratic formula. All right. So let's go through one example. Actually, I lied. Let's go through 2 examples. So EX1, solve using the quadratic formula. So A and B. A is x squared plus 2x plus 7 equals 0. This is important, right? Because if there's no equal sign, you can't really solve for it because it's not an equation. It's an expression. And x squared, ooh, getting tricky, minus 2x minus 7 equal 0. What I'm going to do off to the side here in red, just so that we remember it, we say that the quadratic formula, let's see, does that show up? Oh yeah, it does actually really well, is negative b plus or minus the square root of b squared minus 4ac all over. So what I'm going to do is I'm just going to split the rest of this whiteboard into two. Give this guy a little break for a little bit. Alright, so in A part, we need to figure out what our A is, what our B is, and what our C is. What's really nice about this form is that I haven't given it to you factored. I've given it to you in the standard form, A x squared plus bx plus c. So A is just 1. B is just positive 2. And C is just positive 7. So what I want to do is I want to plunk it into here. So wherever I see a B, I'm going to use 2. Wherever I see an A, I'm going to use 1. Whenever I see a C, I'm going to use 7. So x for A, x equals negative B, negative 2, plus or minus the square root of 2 squared. 2 squared minus 4 times A, which is 1, times C, which is 7, all over 2 times 1. Now we just need to go through the motions of simplifying. So we have negative 2 plus or minus the square root of 4 minus 28. We have a problem here. Why? We have a negative radical. Or radicand, really. Over 2. So x equals negative 2 plus or minus the square root of negative 24 over 2. Guys, at this point we can just stop and say, there is no solution. There are no real roots. Why? What the heck is the square root of negative 21? I don't know. It doesn't really exist in the real numbers, which is what this course is dealing with. Imaginary numbers, another story. But you'll figure out about those in your university degree in math. Okay? So what I would say is no real roots. Or what I could also say is no solution. Okay? So now I want to do B part. This is going to change just a little bit. We have our, at this point, if you wanted to try it on your own and then pause the video and then check your answers, that's good, especially if you're working in pencil. Great idea. So A, B, and C. Can you see? Oh yeah, good. I'm going to move that guy up a little bit. So our A is 1, our B is negative 2, and our C is negative 7. So now I'm going to plunk it into the quadratic formula again. So x equals negative, here's the tricky bit, okay? Negative, negative 2. So negative b, which is negative, negative 2, which is 2, plus or minus the square root of negative 2 squared minus 4 times a, which is 1, times c, which is negative 7. Okay? All over 2a, 2 times 1. So we have, I should say x. Negative, negative 2 is 2 plus or minus the square root of 4, because negative 2 squared is 4, okay? Minus negative 4 times 7, so we're going to have minus negative 28. We like that because that turns into a positive. All over 2. Now we're just going to simplify it. 2 plus or minus the square root of 32 over 2. I know that 32 is just 4 times 8. If we pull out a 4 here outside of the radical, it becomes a 2, so it's 2 root, actually, the better square root factor here is 16, right? 16 times 2 is 32. Square root of 16 is 4. So I'm actually going to have 2 plus or minus 4 root 2 over 2. Now I know you guys don't like this kind of canceling out, but I'm going to try to do it. Okay? 2 goes into itself once. 2 goes into itself once, and I have to do this for every single term. 2 goes into 4 2 times. So my final answer, okay, the one that I can put the box around, the total simplified version, is 1 plus or minus 2 root 2 over 1. But do I need to have that over 1? No. I can just say that this is my final answer. That's what the roots are. All right. Now, if you didn't quite understand my explanation or you want to get more practice, you'll see on page 214, I just did the check your understanding questions. There are full solutions for similar questions. All right. Understand that, and then move on to my next example, my next segment. Thanks.